afternoon, everyone. Today we'll be learning a little bit about quadratic functions and equations in one variable with the help of my BBM, Mr. Smiley, made of cardboard, some ropes, as well as some pins. First, the learning objectives of today will be recognizing quadratic function as a many-to-one relation, investigating and generalizing the effects of A, B, and C of a quadratic function, and sketching the graph of a quadratic function. For the first one, recognize quadratic function as a many-to-one relation. Mr. Smiley, can you help me show many-to-one? As we've known, X is our object and Y is our image. For the image of Y when Y equals to 2, for example, we can see that there's 2x that lead to 2. X over here, X over there, which is x3 and x at -3. This is why it's called a many-to-one relation. There is only one point where it is a one-to-one relation. After that, it's all many-to-one. Next, the characteristics of it is curved. So Mr. Smiley can either be smiling or frowning. But it will still be a curve, and this is the characteristic of a quadratic function. There's one curve. Next, there's a maximum or a minimum point. And this rate, this is a minimum. If it's frowning, it's a maximum. And the third one is the axis of symmetry of the graph is parallel to the y-axis. So if we were to squeeze this, make sure we're trying to squeeze the same amount of length. Ta-da! This line is symmetrical to the y-axis. In this case, it's a little bit on top of the y-axis. Maybe let's do it over here. Let's change Mr. Smiley a bit. There you go. Again, squeeze. There you go. This is the y-axis, and this is parallel to the y-axis. Next, investigate and make generalization about the effect of changing the values of A, B, and C on the graphs of the quadratic function. So, Mr. Smiley, it's easier for him to understand it as A is when he's smiling or frowning. If A is positive, Mr. Smiley is happy, smiling. If A is a negative, so Mr. Smiley will be frowning. That is A. Next, B, depending on that smile or frown, the minimum or maximum point is at the left side or the right side of the y-axis. This is the y-axis. This is the minimum or maximum. Let's just do one. Let's do two actually, so that we don't make a mistake of what B is. Is this a B or is this a P? It's a B. So when the B is in smiley mode, if it's a negative, the graph will be on the right side of the y-axis. If it's a positive, it will be on the left side. This is known by the length of the B. The B is over here, negative is here. Positive is on the empty side. Now, if it's frowning, if you notice, this is a P. So, we shift it. Now, it's a B. Then the B will just be the other way. So a negative will be on the left side of the y-axis, and a positive will be on the right side of the y-axis. That's how the B works. Now for C, y-intercept, this is straight away the name itself. If C is 4, for example, then the curve will intersect the y-axis at 4. Example. Next, sketch graphs of quadratic functions. So we have an example which is y equals to x squared minus 2x minus 3. First of all, we start with our y-intercept or our c. Y-intercept is at negative 3. I have one just nice pin here. Negative 3. Next, is our x positive or negative? Positive. Hence, Mr. Smiley is smiling. Alright, so we're roughly getting it there. Next, how do we get our roots? Roots, as you can see, is when y is 0. So we put y is 0, we factorize this, and we will get x equals to 3 and x equals to negative 1. So here we go. X equals to negative 1 and x equals to 3. And the next one is the axis of symmetry. How do we know it's 1? Again, just pull this. There you go. This is the midpoint. So the midpoint is the axis of symmetry. 1. Now we sub this into the equation where y, and we get what y is. 1 minus 2 minus 3 is negative 4. And the plus minimum point is at negative 4. There you go. We are done with the sketching. This is what the graph will look like. Thank you, Mr. Smiley. Roughly the curve, roughly the quadratic. Next, we will be going to 3 questions from trial SPM as well as the real SPM. This is from trial SPM SBP. So, question is, shows a graph of quadratic function. So, we have to find the axis of symmetry. What do? We'll just follow this. Negative 3 and 5 is the roots, or are the roots. So, just get there, Mr. Smiley. 1 at negative 3, 1 at 5. Now again, how do we get axis of symmetry? We squeeze and make sure it's the same length. There you go. Your axis of symmetry is at 1. Is it the same length? Very good. The answer of 9 is B. Let's go to the next one. Which of the graphs represent y equals to x plus 1 and negative x plus 3? This is from SM 2019. First, we'll get our A. What is the A? Because this is in a quadratic form, another different quadratic form, roots form. So x multiplied by negative x, we get negative x squared. Again, it's a negative. So Mr. Smiley will be frowning. Right, so that's the start. Next, what are our roots? So when y is 0, x equals to negative 1. So 1. Next one. When y equals to 0, x equals to positive 3. Let's take a look. Is there any that represent this? Already. So we have only 1. The roots are similar and it's the same shape. So do we have to go any further into this? No, we do not. Okay, the answer is A. Next, 13. Given the quadratic function y equals to ax squared plus 9x plus c, a and c are constants. If a is negative 1 and c is negative 18, which graph represents this function? This is from SPM 2022. Our A is negative 1, hence it is again a set graph, or a frowning smiley. Our B is 9, which is a positive. But let's not go there yet. We'll go to C first. Our C is negative 18. Unfortunately, Mr. Smiley does not have the capabilities of negative 18, but we'll pinpoint it here roughly, so we'll have a rough image of what this would look like. So Mr. Smiley will be frowning and will have an intercept at negative 18. And the last part is B. Again, the B is positive. All I have to do is get this in. Remember, don't confuse yourself with a B and a P. Is this a B or is this a P? This is a P. So just have to shove it a little bit deeper. This is a B. Right? And the B is a positive. Hence, this graph will be on the right side, or I mean the minimum or the maximum point will be on the right side of the y-axis. So which one represents this? Very good. Only one answer leads to it, which is C. You have to find the roots. Since we're already here, we are roughly done. Thank you for listening, and thank you, Mr. Smiley, for helping us. So how is Mr. Smiley helpful? It's very helpful in terms of the flexibility of making a graph at any given time. At the moment, just using a BBM. Of course, we have internet usage like Desmos and graph calculators, but without this is more of a hands-on experience with Mr. Smiley. Thank you.